A very good afternoon to all who have just joined us at Tech Innovation 2021. The next program on smart and sustainable built environment will explore how technology solutions can improve energy efficiency as well as new business model innovations for green buildings. Before we start in a few minutes, I would like to remind everyone that all attendees will be muted throughout the session. Should you have any questions during the presentation, please type them in the Q&A feature on your screen. We will answer as many questions as we can during the panel discussion towards the end of this session. Paul Churchill of Vertiv will kickstart this session with his thoughts on how sustainable technologies can overcome data center challenges. Paul?
Thank you very much, Alvin, for the introduction, and thank you for the opportunity to talk here today, and for everyone who's taken the time out to attend today's session. I think first up, I'd just like to talk about the obvious, and that is the huge demand that we're all currently seeing with regards to data and data intensity. So when we look at the whole data transformation that's occurring, data demand, whether it's coming from data centers, communication networks, or industry, there's no doubt that we're seeing a huge growth in this area. And as a result, we've all become very reliant on data and the speed of that data and the accuracy of that data. And that's the play that where Vertiv is very much engaged in this sector of the market, and that is providing the hardware, software, and infrastructure to help support these large data centers. So if we look at industry trends, we see that obviously the significant driving of digitization, and it's coming from two sectors. It's coming from the business drivers for digitization. So we're seeing improvement required on business processing, operational improvements, optimization, all of the computerization with fintech and all those other types of industries. And then we're seeing it also from a technology perspective. So AI, 5G, IoT, edge, cloud computing, streaming, all of those new technologies are creating a huge amount of demand. And as those technologies are better understood and incorporated into business environment, you're seeing the utilization of them more and more. And hence what we're seeing is this fantastic demand for computerization and digitization. So what does that mean, and how does that relate to Singapore? If you looked at global demand for data center, which is where all of this data and information is being housed and transacted, data centers account for about 1% of global electricity usage, which is significantly less than a lot of other industry aspects. But what we've seen in recent years is a decoupling between the data center and internet traffic and energy usage. So you're starting to see how that all pans out and has an impact on infrastructure. And Singapore in particular, if you look at Singapore, the actual data centers here account for about 7% of the country's total electricity consumption. And so to put that into perspective, in the last 5 years, approximately 14 data centers with a IT capacity of about 768 megawatts were approved for construction, compared to the 12 data centers with 370 megawatts in the preceding 5 years. So there's no doubt we've seen an explosion of data centers here in Singapore, and all for very, very good reasons. Because of the stability, the environment, it just provides a great central location for the region, as well as globally to provide data center hubs here in Singapore. But as a result of that huge data center demand, it's actually put a lot of pressure on some of the infrastructure. So as we know, Singapore is an island state here, so we have a shortage of available land, and also not so much from a power generation perspective, but particularly from an energy distribution perspective. Large data centers with large capacities, like we're seeing, put a strain on the infrastructure system. And so as a result, what we're seeing is multi-story data centers, data centers with a lot higher densities than what we saw before. And so as a result, apart from the infrastructure aspects it's having on Singapore, we also need to take into consideration the sustainability from a global and environmental perspective. And so Singapore government has acknowledged that there is a sustainability issue that they'd like to address. So what they've done is they've asked industry just to put a temporary pause on the development of the data center space and look at and understand how we can actually continue to accommodate this demand, but in a more efficient and sustainable manner to have a lot less impact on the environment. And so when you look at the three main areas of that, you talk about sustainability, so the ability to maintain at a certain rate or level and avoid the depletion of natural resources or to maintain the ecological balance. Carbon neutral, so balancing out the total amount of carbon emissions, and also zero carbon, meaning no carbon was emitted from the start. And so they're broadly the three areas that we're going to look at with regards to sustainability. And if you look at what the market's doing, and you look at the big players, I've given you some examples here on the right-hand side of the slide, left as you're looking at it. You know, Microsoft, Google, Amazon, AT&T, Tencent, they've all identified their own sustainability targets. And so as a result, as an end user, and therefore as a customer to companies like Vertiv, this is what their expectation is, and we need to work together as an industry to figure out how we can become more sustainable and drive a more sustainable market. So it's really good that we've got acknowledgement from these big users, and we've got support from the government in initiatives and how we develop sustainability, and together we'll work at how we can derive that. So, you know, so what we need to look at is, what do we want the end game to look at? So we're talking about imagining a world where digital transformation scales up to meet the demand, and we believe that this demand is going to continue to increase as time goes on, but we're doing that with little or zero impact on the environment. So what do we need to do that? So zero losses. We need to drive to reduce the losses from both power and thermal perspective, and that talks about looking at efficiencies, right? Energy efficiencies, losses, free cooling, all those different technologies that we can to make the actual power distribution and cooling of a data center a lot more reliable, at the same time with being a lot more efficient. From a zero carbon perspective, we need to look outside the existing technologies. So looking at developing new power systems that will enable us to move to more of a zero carbon footprint. So there's all sorts of work that companies like ourselves are doing with regards to fuel cells, hydrogen power options to eliminate or to produce a net zero carbon impact. Water is also another big user of the data center industry, particularly when we look at chilled water systems, and if you looked at things like evaporative cooling, particularly direct evaporative cooling, or you look at cooling towers for chillers, all those sorts of things. So developing cooling systems that work efficiently and reliably, but aren't dependent on large volumes of water usage. And then zero waste. And zero waste, we're actually talking about the construction of data centers as well as the operation of the data center. So developing of solutions that use less and are easily upgradable, recyclable, and able to refurbish. And if you look at that cycle where we go right through from sourcing to emitting to recycling, completing that loop to create a sustainable environment for the data center industry as it develops and grows within the region. So we see data center operators already starting to adopt a multi-tier sustainable strategy. And once again, it's based around these four pillars, and that is looking at renewable energy as an option. So trying to attract and source 100% renewable energies and clean generation locally within Singapore is an important strategy. The carbon elimination, as we discussed, moving away from carbon-intensive types of practices, and optimization, looking at the current designs and understanding how we can operate them more efficiently and from an energy perspective, as well as use less water. And as I mentioned, looking at the circular economy of construction and how all of these things fit together. And as you can imagine, for this strategy to work, it needs to be driven from an end user, customer, government, contractor, consulting, total supply chain process to ensure that it all works in synchronization together to achieve the desirable sustainable strategy. Okay, and some of the things that we've done in Vertiv to look at how we can support sustainable data centers from a technology perspective. I'll just start on the right first. We talk about high efficiency cooling. So one of the trends and one of the technologies that we're looking at more and more is high density immersion cooling. So, as the data centers expand, one of the things that we look at is looking at increasing the density of each rack within a data center. So previously we may see, I would say 10 years ago, it was 2 to 5 kilowatts per rack. For many, many years, we've talked about the density increasing, particularly with blade servers and things like that coming on board, but we never really saw the high density solutions appearing in the data centers that we're expecting. That's starting to change now. As we're trying to reduce our footprint, become more efficient and become more sustainable, you're starting to see a lot more computing power being placed in the one rack and the one location. So immersion cooling, for example, can do up to 200 kilowatts. And there's a very efficient method with a PUE as low as 1.03. At this stage, mainly used in the supercomputing type of applications, the really high density applications. But what Vertiv see is that will extend into the data center space as time goes on. Looking at the energy efficiency perspective, particularly utilizing the UPS, we need to completely change our approach there and look at how the UPS system and the generator system and battery storages, how they all integrate with the existing grid and with the existing infrastructure, and how we can use that more efficiently. And do we need to be on full conversion all of the time in an inefficient way, or are there smarter ways to do it by monitoring a reliable, sustainable infrastructure, supply infrastructure, and only use those backup systems when required? How fast can we switch those over? What sort of design parameters do we need to take into consideration with regards to that? And also look at some intelligent demand management and how we could also create different revenue streams, or at least reduce some of our costs for savings and opportunities. Another aspect that we spent a bit of time on is off-grid solutions, hybrid systems or renewables, whether that be wind or solar, or as I mentioned before, fuel cells. We've seen a lot of those types of applications, not necessarily for the big data centers, but definitely when you start getting out onto the edge. You start getting onto the edge where you've got some space and availability. And the telco sector has been working these sustainable solutions for quite some time. So there's a reasonable amount of industry experience in that. And so what we're seeing is as we move from core data centers out to the edge, we're starting to look at some of the off-grid hybrid type of solutions. And even in some of the big core data centers, investigating whether using things like hydrogen fuel cells as a primary source of power rather than some form of secondary source. And as I mentioned also, with an important part of it is water efficiency, and coming up with very efficient cooling systems that use zero water. And above we talked about liquid cooling, obviously is a closed loop system. We also have onboard cooling. We also have chip cooling. There's a whole lots of new technologies around looking at how can we cool these servers more efficiently, even though that they're very high density, more efficiently and more sustainably than what would have been our traditional air handling type of unit or precision cooling unit, which obviously it has been the basis of the design for many, many years. So with all of these four activities coming together, as the industry expands, as we look at development of new data centers with a more sustainable profile, these are some of the technologies that we really do need to take into consideration. So thank you very much. I know this is a very quick presentation. And Alvin, thank you for the opportunity. And I'll be around later on for the panel discussion if people would like to go into a little bit more detail. So thank you very much, everyone, and thank you, Alvin.
Thank you, Paul. Next, we have Benjamin Lai from Kaer, who will elaborate on how the cooling as a service business model can both deliver cooling and mitigate the impact of climate change.
Okay, thank you, Alvin, for the intro. A very good afternoon to all the audience in this virtual conference, and also to my fellow speaker in this panel and Professor Seka, the moderator. It's my great pleasure to share with you how the air conditioning as a service business model could become a more effective, if not the most effective approach to mitigate climate change. We are living in an era of seeing the proliferations of as a service business model across a diverse verticals of different industries. Just to give you a few examples, software as a service. Gone are the days we have to purchase a perpetual software license. We just pay for software by subscription, like Office 365. Cloud as a service, offered by Amazon, Azure, Alibaba Cloud, and so on. Music streaming as a service by Spotify. Video streaming as a service by Netflix. Mobility as a service by Grab and Uber. In 2013, Kaer pioneered the air conditioning as a service business model in Singapore. It is also better known as cooling as a service around the world. And with Spotify, you don't have to purchase and own a collection of CDs to listen to your favorite songs or music. And all you need is an app in your phone. And similarly, with cooling as a service business model, you don't have to own, operate, and maintain the air conditioning system in your building in order to enjoy cooling comfort in the building. In addition to that, it is a very effective way to mitigate the negative impact of climate change brought about by the ever-increasing needs of air conditioning in our buildings. The world is facing serious natural disaster due to climate change. We are seeing extreme weathers due to ever-increasing global average temperature. This is especially so during the Industrial Revolution 2.0, starting from early 20th century, with the advent of all the wonderful inventions powered by electricity, particularly the invention of air conditioning in 1902, which accelerates the increase of global temperature in three ways. First, carbon emission. Air conditioning is the largest energy used in most commercial buildings and second largest energy used in most industrial factories. The air conditioning system in many buildings in the region are still running very inefficiently. Second, the refrigerant used in the air conditioning system is the largest source of non-CO2 greenhouse gases. And the wastage of air conditioning, third, cooling is rather prevalent in buildings. It is not hard to walk into a shopping mall or a commercial office that is not grossly overcooled. And Kaer was founded in 1993 as an energy services company, also known as ESCO, to help building and factory owners to address the inefficiency and wastage in air conditioning system. Over the years, we have carried out hundreds and thousands of energy audit and efficiency improvement programs at many buildings and industrial facilities across the Asia-Pacific region. We have accumulated a huge database and knowledge that enables us to continuously build and operate better systems for our customers. But from 1993 to 2012, all this were done under the old business model. The old and conventional business model in the building industry normally award projects to the lowest price bidder, be it the consultants who design the system, to the contractors that build the system, and to the facilities management company who operate the system. As a result, many systems are poorly designed and grossly oversized. And the culture of racing to the bottom in the entire value chain is still quite prevalent, and this results in overemphasis on first cost during design and build phase, and rising operating and maintenance costs during the lifespan of the air conditioning system. Some point along the way, building owners engage ESCOs like Kaer to fix the problem. However, what Kaer can do with a poorly designed system is rather limited. And in 2012, Kaer decided to adopt a new business model, air conditioning or cooling as a service. It actually is really not a new idea for building owners. For example, the electricity and the water supplied to a building are under as a service business model. You don't need to own a power plant to enjoy electricity supplied to your building. You don't need to own a water treatment plant, for example, to have the potable or clean water or new water supplied to your building. And similarly, you don't need to own the air conditioning system in order to enjoy the cooling comfort in your building under the cooling as a service model. There's no capex to the building owner. The building owner gets to outsource the non-core activities of running and maintaining the cooling system to Kaer. And Kaer bears all the capex and opex to design, build, operate, and maintain the system, and even paying for the electricity and water cost to operate the air conditioning system. And I must make an important point here. Besides consuming lots of energy, the air conditioning system also consumes lots of water, that the previous speaker has touched on. About 30% of the water consumption in a commercial building comes from the air conditioning system. So if Kaer is paying for the electricity and the water, Kaer will do whatever it takes to make sure the system running efficiently every minute, every hour, and every day. And the cost center and non-core business to the building owner now becomes a profit center and core business to Kaer. So the model itself incentivizes Kaer to ensure the system is always running at high performance level. And the building owner just pay as per use and enjoy the cooling comfort. So this is how our business has grown since 2013. Today we have $50 million of air conditioning asset under our management, deliver cooling to 10 million square feet of floor area, saving 50,000 metric tons of CO2. And our portfolio includes data centers, manufacturing facilities, educational campuses, commercial buildings, shopping malls located in 2 countries, Singapore and India. And these are some of the air conditioning plants we have built to serve our customers over the years. Every system is carefully designed and purpose-built to suit each building or facility, integrating the best design know-how, the most efficient equipment, and controls algorithm to attain high performance, reliability, with prolonged lifespan as one of our key objectives. We use our resources and finances prudently. We rightly size the system, so not only we reduce the operational carbon emission and water consumption, we also reduce the embodied carbon come along with the equipment and materials we use to build the plant. And this is a chill water plant we built to serve an industrial estate in India. It's carbon neutral, and the solar harvested is more than enough to replace the energy consumed by the chiller plant. It is also water neutral, or zero water, as what Paul has talked about. 100% of water used is harvested and recycled on site. So the cooling as a service business model is a win-win-win partnership with our customers as well as with the environment. And because of the recurring revenue and stable cash flow we enjoy through the business model, we have the time and resources to focus on our long-term strategy. In 2015, we embarked on our first digital transformation journey. And with support from the National Research Foundation, we developed our Break software, which is an artificial intelligence algorithm layered on top of our rule-based control system that enable us to optimize our chill water plant performance autonomously with minimum human intervention. And in 2020, the year of COVID-19 pandemic that caused us to think about accelerating the digitalization even more, we embarked on our second digital transformation journey. And we are constantly looking for partners and higher institutions to develop solutions in the area of IoT, AIoT, predictive maintenance, explainable AI, digital twin, and 5G. So in conclusion, cooling as a service has transformed our business. It changes the relationship, interaction, and dynamics with our customers. We have more delighted customers than before, and we also get the opportunity to play a part in saving the environment for our future generations. Thank you.
Thank you very much, Ben. Nilesh Jadhav from Chi Square will now share on the technology solutions and challenges to improve energy efficiency as well as new business model innovations for green buildings in Singapore.
Thanks, Alvin, for the kind introduction. I hope all of you can see my slides and I'm audible to you as well. If all is good, so thanks once again for inviting me for this presentation. And a big hello to all the speakers, the participants, as well as the panel members that we'll be speaking to later on. So I'm going to share a bit more about the digitalization of the built environment. I think the theme seems to be pretty much there from the previous two speakers as well. So I'm going to elaborate more on from what we do in that journey and how we actually solve some of these issues around creating a sustainable future through digitalization. So I think we already spoke about this. Maybe just like to quickly highlight the trends that we are seeing post-pandemic. Clearly, there's a trend around green plans around the world. Singapore has announced its own Singapore Green Plan 2030 in February earlier this year. There is a EU Green Deal and there is a new Green Deal in the US as well. So all these plans are basically good in terms of focusing the attention clearly on sustainability and climate change. What is noticeable is that buildings take a center stage in most of the plans, rightfully so, because apart from the huge number of buildings which are there today in the world, building contributes to 30% of global energy use and 40% of global carbon emissions. So the problem that I would actually like to pinpoint here is existing buildings of all sorts. It could be retail buildings, data centers. There is a lot of money actually spent every year, about $150 billion per year estimated spent on greening buildings, and that is growing at a 9% compound annual growth rate. And I'll argue that the growth rate of that spend actually will go even higher. So all the tools that we saw earlier on data centers, on cooling as a service, I think all of them will become a very important aspect of green plans in the future. On the right-hand side, you'll see second key aspects, which is the digitalization. So I had actually made this article and published this talking about the data transparency in the built environment, which is right now seems to be very poor, and I'll elaborate more on that. But how do we really learn from the lessons that we get from COVID-19 about data transparency? How important is data? What if we could not share the data of COVID-19 at the right time and the right place? How could we actually mitigate that crisis better by sharing data? So in the building industry, there is an involvement of data technologies such as IoT, cloud, digital twins, and we will talk about that a little bit. But essentially, digitalization is a journey on which the green building or the building industry has just started on. Now, green buildings, of course, present a huge opportunity. I think some of you would already know this, but I borrowed this slide. It's a bit old slide, but it presents a good amount of data in terms of which industries can contribute the most towards carbon emission reduction. And I particularly like this because it also gives you on the y-axis the carbon emissions that could be reduced, but on the x-axis it gives you the quantum of your US dollars that you need to spend to get per ton of CO2 reduction. So you'll see here that, for example, in the buildings domain, less than 20 US dollars per ton CO2 equivalent, this is the amount of CO2 that can reduce. So it actually nicely categorizes the different investments that are required in each sectors. And clearly you can see the building industry is on the high side. That means opportunities in different segments of investments, the low side, the high side, and the very high side, let's say greater than 100, is also there in the building industry. So I think that's the key message from this slide, that if you look at other industries as well, they do present good opportunities, but the building industries present juicy and low-hanging opportunities that could be exploited for carbon emissions reduction. So also talking a bit about the building technology involvement. So clearly, like I said earlier, built tech or the digitalization of buildings is evolving. The building industry is not on the forefront of digitalization as of now. I'm sure it will get there one day, but it is only second to agriculture in terms of the last one to adopt digitalization. So things have been moving, fortunately. There have been a lot of new technologies like what we heard earlier, cooling as a service, data center technologies from Vertiv. These are coming up over time, and there is a clear growth in these technologies that you can see over the last few years. What exactly are built tech? What do we talk about? So when you talk about building technologies, you should look at some of these elements which I mentioned here, like tenant experience, visualization, data analytics, construction technologies, IoT and smart buildings, management of buildings, flexible spaces, real estate and finance. So essentially, there's a lot of VC, venture capital money, that is going in funding startups, in getting their technologies up and running in these areas and digitalizing the building industry as much as possible. As one of the startups participating in this industry, we also feel that we are getting a lot of support as well as backing and funding opportunities at the right time. So this is a time for us, for all of us, to actually move towards a digitalized green building industry. So what are the problems? I think the green building industry, like I mentioned earlier, is a bit slow in adopting digitalization. What seems to be the problem? One of the problems is that things are done in a very disjointed and a fragmented way in the building industry. So a lot of efforts are happening on greening, on climate change mitigation, but they tend to be disjointed. Namely, the stakeholders like the building owner, the building manager, the consultant or the expert who provides that kind of an advice, the financier who provides the fund for going green, and the product suppliers who actually come up with innovative ideas, like, for example, liquid cooling that was mentioned earlier for data centers. They do not have a way to effectively share the know-how and data. So if basically there was a way for every building to quickly find out the possibility of using a new cooling technology and do that on a digital front, that would be a winner. That would give us an edge in terms of accelerating the whole process of doing green projects. Notably, the green projects come in different formats, but then the sequence is that we start typically with an assessment or finding out what exactly has to be done. Then we look for the money to get it done. And then eventually we start getting the things once the money is settled. These functions of assessment, finance, and procurement sometimes lie within the building owner or manager domain, but sometimes they require external help. And that's where the problem starts, because the technology suppliers and the consultants are not able to collaborate effectively sometimes. When the building owner moves from one consultant to the other, or from the one technology supplier to the other, there is effectively a data loss in terms of the knowledge that is required to build a green building project. So we have thought about this problem in terms of the assessment layer, this first layer of doing any project, which is to find out and do an energy assessment of a building. So a typical consultant basically spends a lot of time on the assessment because it tends to be quite manual, is not easily accessible to all the third parties until the time that the assessment is done. So for example, how do you get the best technologies into the assessment? How do you find out which are the best technologies to include in the assessment? Which building data is available? So it's not easily accessible until the time that the assessment is completed. It is quite expensive because of the manual labor which is involved, and also it is limited, that's why. So because it's expensive, sometimes the building owners or the managers only do certain specific assessments in the building. One example is, for example, cooling, which was mentioned earlier. So cooling is one of the biggest load in the building, but then you need to also look at cooling holistically. If you could put a window film and put a better, let's say, lighting and window technologies, you could actually reduce the cooling load. So if this holistic view sometimes is missing in terms of addressing the overall impacts that the buildings can, or the building potential can have in terms of energy saving. I want to give an example which I've been personally involved in. So I was actually working on the NTU campus, and my role was, there was an eco-campus manager. So essentially, together with the facilities team at NTU, we were looking at how we could make the whole campus green and achieve a very ambitious target of 35% reduction in our energy, water, and waste intensity by 10 years' time, and contribute to the Singapore Green Plan going further. So what you could see clearly from this picture is a lot of solar panels, right? So you could see that most of the rooftops are covered by solar panels, but you'd also see a lot of diversity of buildings. There are different buildings. There are laboratories which have high plume fans. There are different kind of new architecture buildings. There are buildings which are very old architecture, etc. So how do you make that entire campus green was a question that got us started in terms of this journey of finding out the digital solution for it. Right? So of course, the most efficient way would be to do it digitally. If not, people tend to take shortcuts. One of the shortcuts that we took consciously was to put a lot of solar energy on the campus, like what you see here. But we noticed that clearly it meets less than 5% of the annual electricity demand of the campus. That means we have to do more. To achieve the target of 35% or better, we have to do more than just slapping on solar panels on the rooftops. It is very important to have solar panels as a renewable energy source, but then we also need to look at how we could reduce the energy efficiency, or improve the energy efficiency rather, reduce the energy footprint before that. So we came up with this solution right when we were sitting within the campus of using a building physics and AI-based tool that could be able to do a lot of analysis on the fly, such as energy analysis and operation analysis. We could also do technology fit analysis, which technology will fit which building, and also do financial due diligence analysis for the financiers to make sure that they can participate and get the data that is required for any green projects. So the way the process works is that we create virtual models of buildings using this building physics and AI technology, and then very quickly get data and allow participants, such as the consultant, the technology supplier, the financier, to start participating and collaboratively work towards making a building project or making a building green. So if we are moving away from a manual assessment, for example, which requires very specialized skills, requires a lot of site visits for experts to collect data. It requires a lot of background, it requires a lot of back and forth collaboration or coordination, and oftentimes there is also duplication of efforts. Inevitably, as a consultant, when we go to the market, we see a lot of issues that happen. And that's the reason that as a company, we have decided to stop doing consulting, but rather give consultants a tool that we have, which is focused on digitalization. So how do we do that when we go towards digitalization is we provide ease of access to data and the drawings. We provide remote access to the digital twins that we create on the platform. And then we give access to a wide range of solutions that could easily achieve the workflows that are required to go green or start a green project. So as an interface, we have decided to use an open interface with this philosophy of creating an open database, which could be shared with the entities or with the industry partners. But at the same time, it will allow anybody to access or rather access any building anywhere, anytime, instantly and at a very low cost. Is that possible? So that's the question that we solved in the research domain. And then we bring it out as a commercial solution by creating digital twins of entire cities like Singapore, and then allowing access to several stakeholders to click on a building and basically do an assessment quickly. So they could just click on a building as a building owner or a consultant or as a supplier and claim the ownership of the building, do further work, invite other people to collaborate and share data and get access to the best solutions in the market. So what could be possible, for example, is doing baseline energy analysis. A quick report could be possible from the platform at a touch of a button. With another touch of a button, you can get the entire energy conservation measures analyzed for you. You get a whole list of energy conservation measures, along with what could the building save in terms of the saving potential of energy, the investment that is required, and the payback that it would yield in terms of going green for the project. So at a very early stage, this kind of analysis gives a very quick input as to what is possible in the building, how we could actually take the next steps. Instead of waiting for the expert to analyze each and every aspect of the building and waiting for data and technology data to come in, we could use this platform to do a very quick assessment. We also did some validation of the platform. Essentially, the platform has to be, it's digital, but it has to be also accurate. So the models that we've built on the platform tends to be around 90 to 95% accurate. We have done that using the BCA Buildings Energy Submission System report that gives us the annual energy consumption, and we compare the model output that we have on the platform compared to what we get from the best system. And we found that between 90 to 95% accuracy is possible using our models. So once we have that kind of a digital twin accuracy, we'll be able to now start simulating the energy conservation measures and get the best answers for solutions to be done. These are some of the case studies that we have done. We have covered banned buildings in Singapore. We have been able to achieve up to 60% savings in a very quick way to take the whole portfolio of buildings, take shopping mall portfolios, looking at telecom providers, data centers. How do we take data center portfolios rather than looking at individual data centers and do a very quick assessment of what is possible there in terms of renewable energy as well as energy efficiency? And that was some of the work. And not only in Singapore, of course, because it's remote, while we are sitting in Singapore, we have also done projects which are outside Singapore, like in UAE, in the US, and also in Europe. We have been able to help consultants, building owners, as well as technology providers to assess their technologies or their building footprints through a very quick digitalized assessment. So lastly, I just want to share about how digitalization really benefits the Singapore Green Plan. So most of you are now familiar with the Singapore Green Plan targets, which are mentioned on the left-hand column here. So specifically for the building sector, there's an 80-80-80 target by 2030, and there's 20% of schools to be carbon neutral by 2030, and 50% of HDB towns to use less energy. So how do we go about by digitally transforming that? So digital transformation really helps the asset data to be easily available to people, and it can provide a huge list of solutions rather than limiting to any one particular solution. Of course, increasing solar deployment is the next target. Then how do we bring the latest solar technologies, including the building integrated photovoltaics, for example, and bring them to the market and make them ready for assessment at the digital front first, and then later on apply them if it makes sense. Okay. And also the other aspects such as economic and the local enterprise creation. So we want to create expertise in the Singapore environment in terms of the firms, consultants, and the experts who can actually do further work to get more productive by using our system or a platform which can digitalize the entire assessment, and they could then spend more time thinking through, let's say, very innovative business models that was presented earlier by Kaer. This is what the industry needs. We need acceleration through digitalization and very innovative business models that could now take care of going green. So with that, I would end my presentation today, and I'd be happy to take your questions. You could contact me here or also connect me on LinkedIn, and I'll be happy to talk to you again during the panel discussion. Thanks a lot.
Thank you, Nilesh. As we will be moving on to the panel discussion shortly, we'd like to encourage you to submit your questions in the Q&A feature on your screen. The moderator for this panel discussion is Professor Chandrasekhar, Professor, Department of the Built Environment, School of Design and Environment, National University of Singapore. We'd like to invite our 3 keynote speakers back on screen as well. Over to you, Professor Chandra.
Thank you so much. Just give me 1 second. I just make it normal background for me, which is more natural where I am at home. Thank you so much for those very interesting presentations by our 3 keynote speakers, Paul Churchill, Benjamin Lai, and Nilesh Yadav. I think the way we want to probably go through this panel discussion is I have a few questions that have been put forward by the attendees. I'm going to read those questions in no particular order, just the way in which they appear on my iPad screen here. And if I could request the speakers, the panel members, to probably keep your answers short and try to respond to the question direct in terms of key messaging. So the first question that I have here is to Paul. And the question here is from Vertiv perspective, what will be the most efficient approach to meet data center challenges?
Yeah, thank you, Chandra, for the question. I think it's difficult to answer that in a very short period of time, but I think you'd appreciate the fact that I think a major aspect of efficiency will be, I would suggest to you running data centers at higher temperature may be one of the aspects that we could actually achieve something quite quickly. You see some of the operators are already operating at a higher temperature, and ASHRAE has reviewed some of their operating procedures. If we can just get the temperature of the data center up by 4 or 5 degrees, has a significant impact on our overall efficiency. So I'd suggest that that's an easy win for us. As I said, there's many other aspects. But,
yeah. Great, wonderful. There's another question to you, Paul, and this is probably something that all of us think about all the time. So what do you think are the biggest barriers in adopting some of the technologies that you had talked about in your presentation?
Yeah, look, I think, even though I just mentioned, increasing the temperature of the data center, I think a big part of that is a resistance from the end user or the end customer, because everyone's concerned about reliability of service. And so, they're concerned about putting the services at risk. Right. So getting them to change to new technologies and explaining to them the impact that we're addressing with regards to reliability, I think is the biggest concern. Everyone is so reliant on this data. No one can afford a data center to go down. Moving to new technologies, we have to, and coming from a very proven background, I think that's the biggest challenge in making that transformation. And a classic example of that is immersion cooling. Telling a server manufacturer that we're going to completely submerge his server into a liquid and it's not going to have any impact will take a little while for everyone to test and figure out.
Right, great. These challenges always exist, and there are always barriers to introducing something new, think differently. So let me move on to Benjamin for just moving around as the panel rotation here. Benjamin, there's a question to you. And this is probably at the gist of what you are talking about, I guess. So this is about how scalable is the the aircon service model that you shared. You took some examples, you shared some practical applications. How scalable do you think that whole idea is? You're muted, Benjamin.
So air conditioning is a system. Air conditioning system in a building is not a simple system. In a centralized systems, it's like a small factory in a building that require the building owner to have a team of people, or they outsource to some contractors to service it and to maintain it. So I would say, if you want to run it, operate it efficiently and reliably, you may have to put in a lot of resources, either outsourced or in-house. And that's why it's a new idea, a new business model. They encourage building owners to think about, why not you bring a partner in, a partner like Kaer who provide cooling as a service into your building, and you actually put your money or your fund into investment where your core business is. So in that case, your cost center, which is your air conditioning system, can be outsourced to someone like Kaer, and you put your investment into where you are specializing in. It could be, to build a better office environment to your tenants, or to build a better front of your shopping malls to attract more shoppers into your shopping malls, rather than put your money into something which is not your core business, which will distract you from your core business. And so that will actually allow another party to come in to be your partner in the building to make it run better, operate better, and always be maintained a high performance and with the lifespan being extended. All right. So this is the whole idea of a cooling as a service to the building industry.
Right. So there's a follow-up question similar to the one I asked Paul. If this is something that's like a win-win situation for the end user in a building, what do you think might be the barriers, or what have you seen as barriers or challenges in already embracing of such a concept?
Yeah, the barrier is basically the change of mindset. Some building owners still would not like to let go the asset of air conditioning system from their asset and so on, because they feel that, hey, air conditioning system is the heart of my building. How can I let it to be owned by someone else like Kaer? So it's basically a change of mindset that we need to overcome to convince the building owners to adopt a new business model. So those customers who has come on board, they really discover that it's really such a good model. And most of the customers we have are delighted customers that compared to the old contract we have with them, under the new contracts, they are basically worry-free. They sleep better at night, especially the factories and data centers. They can sleep better at night as they know that someone who run the plant for them and can run it reliably for them, because this is our core business. This is what we're passionate about. So it's basically a change of mindset, which is the biggest hurdle.
Thanks, Benjamin. Let me go to Nilesh. Just give me a moment. I'm just scrolling down the question list to something Nilesh shared us. So Nilesh, the question that I'm seeing first, that's appearing first on my screen is jumping all over the place. Just give me a second. So with digitalization, again, it's jumped over. With digitalization being the main focus that you were talking about, Nilesh, in your presentation, just a second, it's again gone over. Hang on. Yeah, with digitalization of the information that you were talking about, there would be concerns about, I suppose, security and the data being, safe and sound with the owners and with the stakeholders we need to be looking at. How do you think that can be handled? I would imagine something like that is always a barrier in the whole digitalization process.
Thanks for the question. Yeah, I think we get that question asked quite often because we are dealing with data, digitalization, data transparency. I think that all data transparencies always have to be looked at as a two-way sword. We can increase the transparency, share more data, build common knowledge, but at the same time, it can expose us to threats and privacy attacks, right? So we don't want to inadvertently share private data. So the way we manage that is basically by essentially knowing that this will happen and creating the right channels or right security channels there. So for example, we host all our data on the cloud. We have the cloud reliability to focus on. We don't do it ourselves. We rely on the likes of big companies like AWS, Azure to take care of the cloud security and the cloud reliability. At the same time, we provide our layers of user authentication, which is basically, again, world-class. The technology available today for user authentication, the steps that you need to do are world-class. So we just rely on them and make sure that the data that the user provides is still private and confidential to them. Now, the third thing, which is very important, is that if we only do that, we won't be able to gain common knowledge. So how do we go about doing that? So what we do is basically create a layer of aggregate data analytics, where basically all the private data also seeks in and goes to an analytics layer, where we can say, now I have thousands of buildings data, and now I want to make sense of that and bring back up the insights from all these data that we collect. So for example, buildings could be compared to each other. Building solutions could be compared to each other. We could, for example, see which solutions are being used in buildings and what kind of savings are they providing at an aggregate level, right? So not really confidentiality or revealing what is happening in terms of projects, what is the cost of the project, but rather giving an aggregate analytics available to the industry. So just like, give an example of if you book a hotel, you'd see that so many people in the region booked a hotel, right? So you would actually feel more confidence with your decision, and you'll also get more insight as to what will happen. And at the same time, if you're able to give a CO2 recommendation that this hotel actually gives you better CO2 savings, right? So that could be even better. So that's exactly what we propose to do, is to basically make sure that we keep confidential data where it is, use the reliability of the cloud as much as possible, and then put a layer of data aggregation that can provide the insights.
Right. Thanks, Nilesh. I have a personal follow-up question on this.
Sure.
A lot of this digitalization effort in any sector, specifically so in the building sector, the built environment sector, where the end user, the occupants, as one of the key stakeholders, are an important player in the whole process. How much your energy performance is in terms of efficiency, and how well you're using your resources from the point of view of energy and electricity and water and those kind of aspects. How much of this, the user engagement, the end user engagement, do you think is critical in the success of the whole equation that we're talking about?
Yeah, I think depending on the industry, again, data center is very different. But if you talk about office buildings, retail buildings, the user engagement is quite important. And I think you have the answer also, Prof. Chandra, you have been researching on this. User engagement is really crucial in some places. And I would argue that it can actually, if you use it across the board, it can create a very effective mechanism to help the building owners to identify issues and get solutions, right? And also at the same time, display to the users that they are actually participating and working in an energy efficient, carbon efficient building. So one of the barriers that we see with doing that is the technicality of it, right? So oftentimes users are not worried about, they don't know what kind of chiller they have, what is a tonnage, what is a kilowatt per RT. They should not be concerned with that. They should be able to see the performance in the term that they are used to in their day-to-day life. So what is my payback? What is my ROI? What is going to be my building's footprint, right? How does my building compare to other buildings that my friends are working on? So we have tried on the platform to kind of water it down to a certain level, at least on the open data front, so that we can make users like this, who are non-technical, aware, and also to some certain extent that start participating. They could actually click a few buttons, simulate the building without knowing anything about the air conditioning or the lighting of the building, and then share it with the building owner, and they will say, what's happening here? Why is my building not saving compared to the other building, right? They might have a completely wrong answer to start with, but again, the engagement is important. I think that's where the engagement starts.
Right. Okay. Thanks, Nilesh. Paul, I'll come back to you with a question that I think I saw over here. In terms of the renewable energy resource as a utilization, I suppose utilization function, how do you ensure the stability and the reliability of it? Are there any specific technologies that you are looking at to ensure the reliability and stability of such renewable energy resources?
I think the main, the main one we're looking at the moment would be fuel cells. We'd be looking at fuel cells in particular, and the different fuel cell technology. As one of the other speakers mentioned there, we can go with solar and wind, but the reality is that's not going to provide us with 100% of the supply that we need. It's a nice little little complement and a reduction, an improvement in our efficiency, but it's not a reliable source. So there's still a way to go with regards to the technology. And as I said, some customers that we're having early discussions with are looking at fuel cells as the primary source, and actually having the grid as a secondary source. So if you think about it from that perspective, actually the reliability is quite strong in the fact that you still have main supply there as an alternate source, as your backup source. The issue is really talking about people feeling comfortable with the technology, particularly hydrogen fuel cell and things like that, and making sure that it's safe and the technology is proven.
Okay, thank you. I got some general questions here. Some from the list that came on my iPad, and also something that I jotted down as I heard the presentations. A general question to me here would be, if we want to maximize the performance, sustainability, and the energy performance of, say, very specifically data centers, the approach in terms of how you look at the energy components, energy elements, how much of an exergy-driven approach you think is at play in whatever you are doing in terms of technology? What I mean by the exergy here, just as a very quick overview approach is, you try to make use of energy at different levels of its availability for whatever purpose you want to make use of. So is that something that comes out strongly in the way you would probably evaluate a technology or even a concept, or just a fundamental principle of it? Any one of you is not necessarily directed at any particular speaker. Is a general, is exergy an important discussion point here? So again, my example would be something like, if you have a power plant of some sort, you use a primary fuel to produce electricity, then you have byproducts that can be used for something else. So trigen, cogen, are all of these kind of things still viable proposition in the context of delivering, taking Benjamin's point of, he's delivering comfort as a commodity, for instance, in commercial buildings, or in data center, you're talking about some kind of performance parameter metric per unit energy consumption. How much of such fundamental principles are still being evaluated?
Maybe I give a try to answer your questions.
Sure.
So from my perspective, as I shared just now, there's our central plant in one of the estate we have in India, for example. We achieve a zero carbon status, not because we can build a solar panel on the rooftop and so on. We also partner with another solar as a service provider. All right. So I believe that if we want to adopt any technologies, as long as we can find another specialist, another vendor that specializes in a different field, and we come together and collaborate and integrate our system together, I think we can achieve much higher performance as compared to the building owner, the estate owner himself, try to do everything by himself. So I believe in a shared economy, of collaborative through specialists in different fields. For example, Kaer can collaborate with Vertiv. If you work on the data center, can work on cooling system, and Vertiv can work on the data center aspect of the building. All right. So I also can work with Nilesh, on digital twin. How to use this digital twin to help me to improve my performance. So I believe in future, right, is collaborative across different verticals of the industry to come together to make a building much better than before.
Great. Thanks, Benjamin. Any other thought on this? We are almost running out of time. I wanted to just try and round up this panel discussion. Any other point on this, Nilesh or Paul, would want to add?
Yeah, Chandra, I think the only thing from my perspective, obviously data center demand is pretty constant, right, throughout the 24-hour period. But it's always interesting to have a look at the demand, the load demand profile of a region or of a country or a particular customer. And I think that's one of the things we need to look at. When you're looking at a constant generation, what can we actually do to continue that generation in off-peak times and store some of that energy? Whether that generation be through solar or wind or some of those other alternatives, or even just traditional generation methods as we see the load profile peak and change. And so,
okay. Great. I'm going to just post one last word. and ask you to respond how it applies to your own proposition in 30 seconds each. What does innovation mean to you in all that you're doing? Paul, let's start with you.
Yeah, look, I think for me, innovation, we've really got to open ourselves up to new ideas and concepts. For me, I think the technology is there. We just got to be more open-minded about applying that and having the urgent need to be able to respond to that innovation.
Great. Benjamin, your thoughts?
Okay, I believe we need to be passionate in what we are doing. If we are passionate in what we are doing, I think it will give birth to innovation in our job, in our career, and in our business. Yeah, this.
Great message. Nilesh?
Yeah, I had a similar thought like Paul, really to address the urgency of the situation, accelerate the whole value proposition that we can provide to green buildings and to the climate. I think that's where innovation can serve the best. Of course, it has to be looked at the right filter with the right expertise and resource correctly.
Great. Thank you, gentlemen. Paul, Churchill, Nilesh Jadhav, and Benjamin Lai. Thanks for all your great insights and presentations. It's been a wonderful session. I thoroughly enjoyed listening to you. And thanks for your very, very open discussion during the panel discussion time. And with that, I will pass the screen back to our MC on screen. Thank you.
Thanks, Professor.
Thank you very much, gentlemen, for that very engaging panel discussion. We've come to the end of the second thematic session of the day on smart and sustainable built environment. Thank you to our speakers and to all attending this webinar for your active participation today. Please click on the info button on your screen to submit a rating out of 5 stars and your feedback before exiting this session or joining the next one. Stay tuned for the next and last segment of the day on sustainable solutions in recycling and waste to worth at 5 p.m. Singapore time. Thank you.